Let's take a look at section 8.2, confidence intervals for a population mean, standard deviation, unknown. We're going to continue creating confidence intervals, this time using a much more realistic scenario where we're trying to estimate mu, the population mean, and we don't know sigma, the population standard deviation. And there are two changes that we're going to do. First, we're going to use S, the sample standard deviation, right? The standard deviation we get from our sample. And instead of using Z for our critical value, we're going to be using T for our critical value. Now, there's a complicated technicality going on there, but for our purposes, we're just going to be replacing sigma with S and Z with T. And so here's how we do it. Remember that our intervals are centered around the point estimate, which is the sample mean. Or I should just say maybe is the mean of a sample. Of a sample of size n from a population with, now remember before we knew sigma, here we don't know sigma. So given a sample size of n greater than, I'll just say greater than 30, or any n from a normal population with mean x bar and sample standard deviation S, we create a confidence interval as follows. Find the, got that, weird. Find the standard error, which we denote SE, which by the central limit theorem is SE equals, now in this case, it's not going to be sigma over root n. That's what it was before. Now it's going to be S over root n, where S is our sample standard deviation, because we don't know sigma anymore, so we can't use it. Next, we decide on the appropriate level of confidence, often 95%. That stays the same. After finding the degrees of freedom, which is simply n minus 1. There's a technical reason why we use this, but df, our degrees of freedom, is just n minus 1, sample size minus 1. We use charts, or in our case, we're going to use Excel to find the corresponding critical value. And the critical value is going to be T alpha over 2. Remember last time it was Z alpha over 2? This time it's T alpha over 2. It's called the student's T distribution. And then we're just going to do the same thing that we did last time. We're going to find the margin of error. Right? And that's going to be, again, the same sort of thing it was before. Standard error times your critical value, which is just your, well, actually, instead of writing standard error, we write S over root n times our critical value. And then the interval, x bar, right, sample mean minus margin of error, x bar plus margin of error, that is our confidence interval. Which means we are, and again, we want to be careful with this phrasing, 95% confident that the true mean is within the interval. In other words, if we kept taking these confidence intervals over and over again with different sample means each time, then 95% of the samples would contain the population mean. So I hope you just see that this is a very analogous process to what we were doing before. The main difference is that we're using S instead of sigma, and we're using a different critical value, T, instead of Z. But the numbers are usually pretty similar, and for our purposes, it shouldn't require any more work. We just need to use a different, either a different chart if you want to use the chart from the book, or really what we're going to be doing, what I'm going to be doing, is using a different Excel worksheet. Okay? So let's look at an example, right? We have a sample size given 44, sample mean 56.9, sample standard deviation 9.1, construct a 98% confidence interval. So what we're going to do here, we have to do a period. If we just open our Excel program, you know what, actually, let's go over here. And we go to one sample t, right? See down here, one sample t? Okay. And if we enter some stuff in, let's enter in our, I think it was 56.9. Sample standard deviation, I think, was 9.1. And n, I believe, is 44. And note that means our degrees of freedom is 43. And they did want a 98% confidence interval. So let's give them what they want. And that's what we get. All right, so if we just take this, maybe just stick it over here, just as a reference, and we can say, hey, maybe I'll, let's erase this, maybe give ourselves a little more space. So we'll say 98% confidence interval equals 53.59, we'll say, to 60.21. There we go. Part B, if the sample size were 30, would the interval be narrower or wider? Now, let's think about that for a second. We, of course, could just plug in 30 into Excel and see what we get. But if you think about it, the standard error, I'll just write this over here, standard error equals S over root n. So as n decreases, maybe I won't use an arrow. As n decreases, that implies that the standard deviation, or sorry, the standard error is going to what? Increase. Which implies that the margin of error increases. Which means that our interval is going to be wider. Our CI would be wider because as n decreases, SE and MOE increase. Okay, and sure enough, if we go ahead and open Excel, and instead of 44, we say, no, our sample size was actually 30. Look at our confidence interval, right? It's a little bit bigger. Not by a whole lot, but it's bigger. Okay. Let's do another example. Number 33, right? Again, sample of certain size, sample mean, sample standard deviation, construct a 95% confidence interval. So let's get our stuff open here. X bar here equals 87.2. We have 5.3. We have 89. By the way, that's a very large sample size. When you have very large sample sizes, T and Z are almost the same thing. Okay. Oh, they do say a 95% confidence interval though. So let's just do that. And we have our interval, right? So I'm just going to screenshot this guy. And we're good. Maybe, can I stick it over here? Let's see. Oh, we've got some space over here. Let's stick it over here. And so, for part A, our 95% confidence interval is 86.08 to 88.32, let's say. Note that that's a very narrow confidence interval. Now, part of the reason was that our sample standard deviation wasn't all that big. It was 5.3. But part of it was that our sample size was really big, 89. Right? So 5.3 over the square root of 89, that's like a little less than a half. Right? So, or I should say a little bit more than a half. A little bit more than a half. Right? The standard error was 56.18. So we're not going to deviate very much from 87, right? One in one direction, one in the other direction, right, for 95%, okay? Right. Now, part B, if the confidence level were 99%, would the confidence interval be narrower or wider? Well, the answer is our CI would be wider. Because, now, one way you could look at this is you could say, well, T alpha over 2 increases as the confidence level increases. That's just a fact. You can look it up, and you can just put it into Excel. But the other reason is that we need when we do 99% confidence intervals, that means 99% of the time when we take these 99% confidence intervals, the population mean should be within the confidence interval. So with all else even, it's going to have to be longer than a 95% confidence interval so that it encapsulates mu more of the time. All right. Now, just want to make a couple of things clear, a couple of prerequisites. Number one, our samples always have to be random. Always. And, of course, our samples also have to be large, greater than 30, or from an approximately normal population. Right? Then n can be any size. Right? So, remember, there are trade-offs from using higher confidence levels, right? We were just talking about 99 versus 99%. Higher confidence level reduces the chance that I should say, I'll say the population mean, mu, is outside our confidence interval, but it increases, right, the length of our interval, right? And that's not great because now there's a wider range of possible values for mu. Right? So we might know that our interval is more likely to, this process, our intervals are more likely to contain mu right before we actually take them. But the intervals might be so big that, our ability to estimate mu isn't quite as meaningful. So let's just take a look at one more example. All right, we've got fake Twitter followers. Again, we're just entering things into Excel. All right. Okay. So in this case, we have the mean percentage of fake followers. Looks like it's 14.1. Sample standard deviation of 9.6. And n, it looks like, was equal to 46. And we want to do a 90% confidence interval. Okay, we can just do that. And that's what we get. So I'll just stick this right here. And we can say, you know, we've got our 90% confidence interval is 11.72 to 16.48. All right, there you go. And let's see, based on the confidence interval, is it reasonable that the mean percentage is less than 10? What do you think? No, it's not reasonable. Because all values in our confidence interval are greater than 10. So, assuming we, took a confidence interval correctly, we took our sample correctly and everything, it would be not completely ridiculous, but it would be unlikely that the true mean would be, would be 10, so far below our confidence interval. Okay. Now, remember before that sometimes we like to set our margin of error at a certain value, and so that requires a certain sample size. We did that before when we knew what sigma equaled, and we could use z as our sample statistic. And you could try to do something analogous with t. Let me just show you how it's going to work out, right? You could say, oh, look, the margin of error equals our standard error times our critical value, which is the same as s over root n times our critical value. And then say, okay, well, if we want to solve for n, right? So if we square both sides, we're going to get, actually, no, so let's not square both sides yet. We're going to get root n equals s over the margin of error times our critical value. And then we square both sides to get, let me put that down a little bit lower. And it's going to become greater than or equal to, right? Because we need it to be at least. And it's going to be s squared over the margin of error squared times t alpha over 2 squared. But the problem with that is that, first of all, t depends on n, right? And also, s, our sample standard deviation, is not equal to sigma. So what we do, as it turns out, is we say, if n is greater than or equal to 30, then we know two things. Number one, s is going to be pretty close to sigma most of the time. It should be. And we also know that t is going to be close to z. So what we can do is we can just say n is greater than or equal to s squared over the margin of error squared times z alpha over 2 squared. Okay? So you see that we're replacing our t with our z. Okay? So if I were to ask you a question like this, what you'd need to do, and of course we always round up as before, but you go to the Excel and you do the one sample z, right? And whatever confidence level we're talking about, like if it's 99%, for example, you would use that critical value, not the t value. You would not use that guy, okay? Or, well, for 0.99, what 0.99, it would be, I guess, this guy, right? Pretty close, right? Margin of error 3.8 versus, oh, not really that close. You would use this guy, okay? And that's what we've got.